question. And it's a bearing question. We have to solve it. It is being explained on how we have to solve it. And I've started it in one of the episodes. I have to stop it abruptly. And I'm starting again now. So if you are joining us for the very first time, you can still rejoin us. Okay. So let's continue our workings. Now, as I said the other time, this is 233 minus 36.112. If you have to solve that, what do we get? At the end of the day, that will give us 269.12. So it means 269.12. Now, we have PR squared. To get our PR now, which is this to this, to get our PR, it means we have to divide by 2. Because this PR, we are using the cosine rule, we have gotten this to be 100. So we have to divide by 2. We have to find the square root. I made a mistake, pardon. We have to find, because square root is what we get it away. So we have to do this. Okay, the square root of both sides. We have to find the square root of both sides. Now, so the square root cancels this square. We are left with this. So it means our PR will be the square root of 269.12. And that will give us 16.40. And we are being told to do it to 3 significant figures. So it means it will give us 16.4. That's to 3 significant figures. Because we are told to find PR, and they say calculate correct to 3 significant figures. That's PR. And that's what we have just gotten now. The next question says the bearing of R from P. The bearing of R from P. It means this place. And that's what I was saying the other time. So the bearing of R from P means from here to here. So we need to get what is internal here. And if you want to get what is internal, we'll be using the sine rule. We'll be using the sine rule to get this. Because this triangle is not a right angle triangle. It's not right angle. It is a triangle that is not right angle. So what do you have to do? We have to find this using our sine rule. Now, the sine rule that we have to use here, let's check it out. Using it with the sine rule, we know this side, we needed this angle. Now, this side has been known now, and the side is 16.4. So it means this will be 16.4, okay, meters. So to get this that is 16.4 meters, what do? We have to use our sine rule, which says this side, which is 16.4, over the sine of the angle. So sine of the angle, that's sine 100 degrees, is equal to, now we have to get this angle, and we know the side. So we have to say 13, which is now 13, okay, divided by, we have to say 13 divided by this angle, which is this. So we have to say sine of that. Now, from here, what do? We did the cross multiplication. So this goes up here. So we have our 16.4 sine theta is equal to, this multiplies this. It means 13 sine 100 degrees. Now, we have to divide, because this multiplication here, we have to divide both sides by 16.4 divided by 16.4. All right? So it means this cancels this. So we have our sine theta is equal to, now we have 13 multiplied by sine 100. Okay? So sine 100 multiplied by 13, what do we have there? multiply by 13. Okay, and after that we say divided by 16.4. okay, divided by 16.4. So that gives us 3.12 or thereabouts. Okay, so let's check it now. When the division is done, after this divided by this, so what we get at the end of the day is 0.7807. So 0.7807. Okay, now to do this we have to find our theta. Theta will now be arc sine of this, arc sine of 0.7807. So what do we get at the end of the day over there? Okay, so our final answer will now be 51.3. So it will be 51.3 degrees. Now it means what we got here is 51.3 degrees. So from here to here it will be equal to 51.3 degrees. And from the questions say we should find the bearing of R from P, the bearing of R from P. So we need this place. So it will now be 50 plus what we get here, that is 50 plus 51.3, and that will give us 101.3. so that's the bearing. So from here to here will be 101.3 degrees, because we have to add this to this, and that is our bearing. Let's look at it from this way. The bearing of R from P. After that we are told, calculate the shortest distance. Okay, sorry, you are not seeing, the visibility is poor. Okay, I will try and make it real, please. This is it. Everything we have calculated, this is it, please. Can you see it like that? Please, if you can see, let me know, please. Can you see it? Is it not too poor? Okay, sorry. So this is what we have to calculate, okay? And this is what I've done. I believe you have seen it like that. Now, look at here. Calculate the shortest distance between point Q and PR. The shortest distance between point Q here and PR. So we have to rule. We have to rule it out in order for us to calculate the shortest distance. This. So this is what we do. The shortest distance will be from here. So we have to rule it down. So when it gets here, it makes an angle 90. So we have to get the shortest distance. How do we go about that? Please, let's try and redraw it here. This is what we do. I will redraw it here, please, as it is. Okay. So looking at it that way, there is we have 50. Yeah. We have 50. So we put 50 over here. 50 degrees. Okay. We have our 8 in this place. So we put our 8 over there. And now we have to calculate the shortest distance. Okay. And we have to calculate here, which is our Q. I can call this place M. So we have to calculate this shortest distance. So using this, look at this place now. Using this, we can use our SOHCAHTOA. This is our hypotenuse. This is hypotenuse. Okay. Using the, and we have to get this side, and this side is the adjacent. So what will bring the adjacent and hypotenuse together? Okay, and if we like, we can use this side, which we got here, as 51.3. You can use that as 51.3. When you are using this, this will be the opposite you have to get, and this will be our hypotenuse. So using this angle, this is opposite, this is hypotenuse. That is sine. It means sine 51.3, okay, will be equal to, now opposite over hypotenuse. What we have to get here? which is our QM as I labeled it, divided by 8. Okay, so our QM will now be cross multiplication. This goes here. So our QM will now be equal to 8 sine 51.3. Now 8 sine 51.3 will be our answer over there if you look at it very well. So which means we have calculated this. When we do that, what do we get at the end of the day? So we get 6.25 meters at what we are supposed to get, and this is what I did, and we got 51.3a. You can see what we have here now. In the diagram, we have PQ, and as I've seen it, we have to calculate this. We have done it. Okay, we have to calculate the shortest distance between here to here, and that's what they said. They say PR, we have done that. The bearing of R from P, that is R from P, we are able to do that. Okay, and we are told to calculate the shortest distance between point Q and PR, that is this PR and Q, so the shortest distance. Okay, so hence the area of the triangle. Now the last thing we have to do is to calculate the area of the triangle. If I have to reconstruct the triangle, and you see how it is, okay, so it means the triangle is like this. This is our triangle, and we have to calculate the area. Mind you, in one of my videos in my channel, I explained that the area of a triangle doesn't necessarily mean we should find the half base times height every time. No, that's not it every time. What we have to do is different from that. And what is it now? Let me just sketch out the triangle, and you see what applies to it. Now we remember that we have 100 here. Okay, and this side is 8 meters, and this side is 13 meters. If you have to calculate the area of this, it's very simple. The area of a triangle normally should be half. Okay, should be half times A times B sine theta. This A means one of the adjacent side. This B means one of the adjacent side. Sine theta, that is the angle that is holding the adjacent. This angle is what is holding the two adjacent here. And if you have to calculate the area of a triangle, the reason why they always say area of a triangle is half base times height, it only goes for the right angle triangle. Look at the right angle triangle. When you have angle 90 here, they call this the height, they call this the base. If you are to use area is equal to half base times height sine, the theta is 90, it's 90 degrees. So sine 90 is always 1. So this will now disappear since it's 1. So that's why we always say area is half base times height. Naturally, it should be half AB sine theta. So now that we have the angles holding the adjacent, and this is not 90, so we have to use the normal formula. So it means the area of this place now, area will be equal to half into our A, we can take any of them, 8, okay, multiplied by 13 sine 100, sine 100. So what do you get at the end of the day there? So if you are doing this now by calculation, yeah, multiplying everything here, you are getting 52. Okay, 52, this times divided by 2, that's 52 sine 100 degrees, and everything here will now give you 51.21 meters squared. Okay, but they told us, they say we should find every answer correct, calculate correct to 3 significant figures. 3 significant figures. And here what we are doing now is 1, 2, 3, 4. That's 4 significant figures. So you have to say it is 51.2 meters squared. That's to 3 significant figure over there. And that's everything we are told to calculate there. Let's look at another question. Look at this. There are 3 cities, A, B, and C, within a state. If city B is 24 meters on a bearing of 150 degrees, the first thing we have to do is to get the bearing, okay, which is 150 degrees. So it means we have to try to draft. You first of all make something like this. So we are told that it is 150 degrees, okay? So from here to here is 90. To this place is 180. So 150 is around here. So we now rule our line just like that. So we are told that there are 3 cities, A, B, and C, within a state. If city B is 24 meters on a bearing of 150 from A, so it's coming from A. So it means it's coming from A and it's going over to what? To city B, and they are 24 meters. So we have to put 24 meters here. And it's going to city B. So let me call this place city B. Okay, now let's go on. And city C is 32 meters from city A. And city A is on a bearing of 015 degrees from city C. Now, from city C, 015 degrees. It means city C is around there. Okay, so it goes like that. Okay, because they told us, and city A is on the bearing of this from city C. So the bearing we were told, which is 015, is very small. 015 is very, very small. Okay, let me rewrite it, please. 015 degrees. Very small. It's not up to 90. Talk less of 180. So that's how we put it there over there. Okay. So let's look at the question again. Okay. On the bearing of this, but they told us it's 32 meters. 32 meters. So we write it as 32 meters. Now this now says calculate the Roman figure 1 distance between city B, because here now is C. This is C. This is C over there. So distance, now we have to calculate distance between city B, okay, distance between city B and city C to 2 decimal places. Distance between city B and city C. Now, between B and C, now, city B and city C, what is their distance? Let's rule first. Okay, we rule like this. To get their distance, we needed this angle, and we are going to use our cosine rule normally. Okay, this one is CB now. So to get our distance, we needed this angle, and the angle we are given here is 150. This angle is 150 degrees. Okay, to get this side from here to here, since the total distance between here and here is 180, this is 180, and this place is 150. So we need to take 150 away from 180. So we have 30. So this place will be 30 degrees. All right. So we need to get this place. Remember, this and these are alternate angles, because this line and this line are parallel. This line and this line are parallel. So it means this angle and this angle are alternate. So this is 15, and this also should be 15 now. Now, find them together. 30 plus 15, that gives us 45. So it means this angle is 45. So we have to go for the calculation now in order to get what we are supposed to get easily. We have to go for the calculation. So how do we do that? It's very simple. Now, to get our, we have to call it CB or BC. So you now say BC squared, okay, is equal to, now we have to take this and this. So it's equal to 32 squared plus 24 squared, all right, minus 2 times 32 times 24 cos, now the angle that is facing it, which is 45, cos 45. Now, if this is well calculated, 32 square will give us 1024 plus 24 square will give us 576. Now, minus, if you calculate this properly, 2 times 32 times 24 cos 45. So if you get that, it will give us 1086.12. 1086.12. So at the end of the day, our BC squared will give us 513.88. 513.88. So it means that to get BC, we have to find the square root of both sides. So we find the square root of both sides. Okay. Therefore, our BC now. So BC will be equal to 22.668. Now, remember from the question, what did they tell us to do? We are told to find the distance between city B and city C to 2 decimal places. So it means we have to say after decimal 1, 2. So to 2 decimal places, it will give us 22.67. Okay, to what? 2 decimal places. So that's our BC. And the question again says, we should find the bearing. Let's look at it. The question says, find the bearing of city C from city B. Bearing of city C, look at it, from city B. It means we should find this from here to this place. Now, how do we do that? Very simple. Now, there's no how we can get here. We can only get from here to here as 180. We are not sure of this, but we are sure of this place. This is 30, alternate angle. This should be 30. Remember, this and these are alternate to each other. So this is 30, this is 30, this should be 30. What we need to do now is to get this place. Once you're able to get internal, we add it to 30, we take it from 360. So the remainder will be what we needed, because we needed from here to here. So that's the best method. You need to get this place. Thank God we know this place, so we can get it readily. We know here, so we can get here. So let me call it theta now. So it means 32 over sine theta. We are using sine rule now. So it means 32 over sine theta, okay, is equal to, now let's take one that we know very well, this to this. Remember, this answer is now 22.67. Okay, so that's what we are going to use. So it means 22.67 over sine 45. So that's 22.67 over sine 45 degrees. Looking at it this way, you can cross multiply to get what we needed there. Okay, so when we do that, sine comes up and this one comes down. So it means sine theta is equal to, this goes up, 32 sine 45 degrees divided by, this comes down, 22.67. all right, 22.67. So what do we get at the end of the day? What we get at the end of the day is that we now have our sine theta will be equal to 0.9979. It is from there that you now have theta is equal to arc sine of 0.9979. So from there, our theta will be equal to 86.3 degrees. 86.3 degrees. So we come back to what we have here. We call this one 86 0.3 degrees. Mind you, we are to add it together. Adding this together with 30, what do we get? 86.3 degrees plus 30. What we get is that, okay, good of you, my girl. Adio, I can see you. So 86.3. Now, we have to say everything together will now be this. It will now be 86.3, okay, plus 30 degrees, plus 30, plus 0, 0. What will this give to us? 0, this will be 3, this is 6. So 116.30. Now, to now get our bearing, which is from year to year, everything will now be 360 minus 116.30. Mind you, everything is 360. And we need it from this place to here. Okay. So it means it will now be equal to what? 360 minus 116.3. So our final answer will now be 243.7 degrees. And that is the answer. Now, thank you for watching this video. God bless you. We meet in another video. Thank you. Good night and bye-bye to everybody. Bye-bye. Thank you.